So we've had our GR Yaris now about a couple of weeks. I think probably one of the first ones to get this in the country. We've taken it for some nice drives around the country lanes and it's been fantastic fun to drive. As you can see, it's still nice and dirty from the country lanes. However, it's time to get to work now. We bought this car mainly to develop the intake system. What we're going to do with this is slightly different to what we normally do with development. We're going to actually take you along on the journey and show you what we do on a step-by-step basis as we develop the intake. So the first step is to take the intake out, the stock intake, and scan it. So we'll do that, show you how we scan the system, the area around the airbox, and then once we've done that, we'll import all the data, take you through that process as well, and step by step as we're developing the intake, you will see what we do as we go along. So I'm just going to start by scanning this sensor which opens and closes the vacuum port on the airbox at the base of it, just to get a reference point for where it is. Because we're going to have to experiment to see what happens once we disconnect this, because I don't think we'll be using this on the intake. It's going to pick up now the top of the airbox, just to give me a reference point for where the maximum envelope is for the stock system. Also I'll be scanning the underside of the bonnet so I can see the absolute maximum, just in case we need to use a bit more volume. I'm also going to scan where the stock MAF sensor is in its location with the stock airbox, because obviously the wiring loom is only so long and we'll need to keep it within the same sort of constraints. So we just finished scanning the stock airbox in place. The reason I do that is to allow me to get just a visual idea of where it sits in the engine bay while I'm designing. Sometimes it helps to give me like a sort of rough ballpark geometry envelope in which to design the intake, so that I don't go too far outside the boundaries for interference with the bonnet and that sort of thing. So that's now done. We're going to remove the airbox and then scan the area around the airbox, which is more important for me, so I can get the maximum limitations of the intake system. And then once that's done, we'll take it from there. I'm going to start by scanning the front duct area. This is where the stock airbox draws in these cold air from as well. So we've actually removed the stock connection. There's like a small scoop which the stock airbox connects to draw air in from the bumper. That's gone, so that we can maximize on the given volume. We'll make our own connection. So I've removed the connecting tube from the airbox to the turbo inlet. I'm going to try and scan behind the engine to see how much space there is to increase the diameter of that tube. Need to take into account the fact that the engine moves back and forward under acceleration, so we still need some clearance between that tube and the rear heat shield. So I'm going to try and get my scanner in there and see if I can catch some of that geometry. So the final part to scan is the underside of the bonnet. That will allow me to have the maximum envelope available for the intake. You can notice there's like a white spray over the underside. This is a special spray which mats down the shiny surfaces to allow the laser to scan better. With that done, we can then look at the options available for the intake. We'll offer in some existing designs to see the spacing available so we can have a sort of visual idea of where to go. So we've removed the airbox and the ducting from the engine bay, and as you can see there is a lot of room to play with here, which is a refreshing change from what I'm normally used to. Now, with this size of engine pushing out stock around 260, 270 horsepower, we would normally go with our medium-sized pod, which is our patented design for the Eventuri system, which is this size. We currently use this in a number of intakes which are making more than the power this engine makes, but putting this in that area, it kind of looks lost. I mean, there's so much space here. I mean, I could easily use this, but we could probably go bigger. So the other option we have is this, which is the pod we used for the Stage 3 RS3 system, which is capable of supporting up to 1,000 horsepower. Now, I know we're not going to get anywhere near that figure with this engine, but visually, this will look more impressive because it uses up a lot more of that ample space in the engine bay. So, first impressions, I think I'm tending to steer towards this design, this size of housing to work with. Now, I may integrate the MAF tube with this as a one-piece system to eliminate the extra interface between the filter and the MAF tube. It will look better, it will flow better, more complicated to manufacture, but that's a challenge I can probably take up later. The other thing to notice is where the ducting will be. So I need to make sure that the angle between the front of the filter and the ducting won't be too extreme. Also balance that off between the angle of the back of this and the tubing and the MAF tube where it goes to the servo. So lots of things to consider, but lots of space to use. And yeah, I think we'll start with this size housing to begin with.
Thank you so much for watching, guys. If you'd like to watch more of this project, you can do so over here. If you'd like to watch what YouTube suggests you might like from our other videos, you can watch that over here. If you like this video, please click on the thumbs up. And if you haven't already, please subscribe to our channel. If you guys have any questions, please drop them in the comment section and we'll do our best to answer them for you.